Assalamualaikum warahmatullahi wabarakatuh. Uh, Today, I want to explain my assignment. Before that, I want to say thank you to my group. There are Hasani Batul Haki, Ernest Pelajar Millennium, and also me, Kevin Sustiandani, with NPM 200 653 7293. In my group, we have to solve the problem number 5. We solve using Gauss-Jordan. The first step, we have to defining the parameters. In this problem, we have cross-sectional area that the unit is centimeter square, and I turn into meter square, and then we have E, or we call it modulus of elasticity, that the unit is Pascal, and I turn that into Newton per meter square. And then I made a element connectivity table. We have 4 elements or trusses: one element, 2 elements, 3 elements, and 4 elements. Each element have a node point E and node point J that was connect the element one into another. For element one, uh, connected to node 1 and node 2, and then element 2 is not connected to node 2 and node 3. The element 3 is connected to node 3 and node 4. Element 4 is connected to node 2 and node 4. Each element has an angle, or we call it theta. For element 1, we have 0 degrees, 147 degrees, 0 degrees, and for element 4, we have 90 degrees. Each element has the length 1.5, 1.8, 1.5, and 1 meter. After we defining the parameter, we open the application of OpenModelica. First, we have to type the create new class. We can call it the Truss examples, and then we have to discretizing the problem into the nodes and elements using the parameter that we have to input the parameter. This first parameter have 7 columns that consist of element. First column is element, and then the next one is node E, node J, theta, cross-section area, modulus of elasticity, and then after that we have the second parameter that have 5 columns, equals to external loads and boundary condition for each node. First column consists of node. The next one is fx, fy, ux, and uy. We have to assuming the solution that approximates the behavior of the element using K, or we call it stiffness. This is small. I hope you can see this. K is equals to member column 5. 1, 2, 3, 4, 5. 5 is the cross-sectional area, multiplied by member 6, or E, modulus of elasticity, divided by member 7, or the length. After that, we have to developing a quotient element using function of stiffness metric element. and look like this. Then end of the stiffness matrix element. After we have the stiffness metric element, we have to convert the stiffness metric element into the stiffness metric global using the this function. Then n and stiffness metric global. After this, we have to assembling the element into the final form using the function of stiffness material final input and output, and then n. After that, we have to apply the boundary condition and the loads using the function of displacement matrix. In this problem, we want to solve this problem using Gauss-Jordan. So we have to call the Gauss-Jordan function. This function of Gauss-Jordan is a little bit long, but is worth for your result. After type this and then end the function, we call it the pre-process, and then we go to the next step is the post-process. In this function, in this function of Truss process is to find the reaction forces, internal forces, and normal stresses, and then find the U displacement result. Okay, I will go slowly so you can see this function. Then end Truss process, and we can go back to the Truss examples. In the Truss examples, before we sorry, no, before we simulate uh, the class, we have to check the model. Then if this uh, pop up like this, it's okay. Then the mesh browser pop out like this too, then it's okay. After that, we simulate. Simulate is a little bit long time. Then I already simulate it, and it will pop out and say it's finished. Then we have the result. The result in this is uh, contains a lot of result. We can choose one in example like the R. R is the reaction forces. The plotting will be look like this, or we can click U, or U is the displacement result, that the plotting will look like this, and then the K is for stiffness, and the plotting is will look like this. After that, we if you want to know the result of internal forces and normal stresses, is that data result in the top of the result. You can click it, all of the internal forces and normal stresses. And then the plotting will look like this. Okay, I think is enough for me. That's all my explanation. For sorry for my mispronunciation and another problem. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.